So I talked earlier about like these groups and how we want to make a lot of them. And like Sidor and Jeff kind of presented about a way to make these centralized groups. And like the idea is that we have this kind of chicken and an egg situation where we want to have a lot of private applications, but in order to have them, we need to have like groups for people to be able to signal from. And in order to have groups, we need to have private applications. So the idea is that we will start with something like InterRep, and we can make these like private groups, and then we can use that to bootstrap like on-chain groups that are completely decentralized that Insun is working on and with other people. And like maybe we can chat about that later. But like the idea is that like we want to build this kind of like ecosystem of private applications. So well, we have these groups, and what can we do next? Like the first thing that we need to realize is that like when you do things in a private world, there's no consequences, right? Because like if everything is completely private and all your actions are private, you can't really be held accountable for your actions. Like for example, there's this social media project called Autism that's basically uses Semaphore to make like a message board. And I think Brian, do you have one called ZK Messenger? Is that the same? Okay.
Not the same, it's a similar idea.
Okay, not the same, but similar idea. So yeah, so people can post however many messages. They can like not be really penalized for the things that they're saying. Like there's no kind of feedback, right? That like when you do things privately, you don't kind of get this sort of feedback. So and because we don't know who is doing something, we're not able to like punish them or like adjust the system so that they have like different properties or different like amounts that they're able to say. The next thing to realize is that like we can do objective things inside ZKPs. Like we'll hear from Oscar later, I think, about ORLN, which is like if someone messages more than X messages per second, we can punish them. I don't like the word punish. Penalize is maybe better, or yeah, I don't know what a good word is, but. This works because it's completely objective, right? But when we're thinking about like the context of like social media, it's not so objective like if someone made a bad post or if someone made an inappropriate post. Like this is like subjective, and like we need to have ways to be able to react to this. And we can't do this inside a zero knowledge proof, so we need to have a way to like deal with this hard problem. And then Vivian is going to tell you how we do that, and I'm going to tell you like the final thing I'm going to talk about is like if we can do this, then it'd be really cool, right? Because we would be able to have like this kind of private world where you're able to like not only like signal about like things that happened in the non-private world, but you can change and adjust, and things can grow, and it feels like this is like an exciting set of applications. And like, we can do all kinds of fun things, and Vivian is going to tell you how to do these things.
Yes, thank you, Barry. I'm Vivian, and I want to introduce you how the UniRep protocol works, and I will demo the social media we built upon the UniRep protocol. Yeah, so you can imagine that there are a lot of applications in Web 2, and we know that there are many kinds of reputation in this application. For example, you have followers in your YouTube, or you have like or dislike in your YouTube video. Or for example, you have stars in your GitHub account. But there are a lot of this reputation, yeah, right? Yeah, but imagine a situation that you are a platform A user, and you want to prove that you have a certain amount of reputation to a B platform user. And yeah, like for this example, Alex wants to prove that he has a certain amount of reputation in a platform. But how can Alex prove that his reputation? Yeah, for example, Alex can take a screenshot in his app, but it will compromise Alex's privacy. And also, the screenshot can easily be forged. And also, another user cannot be convinced, yeah, because it's really easily to be forged. Yeah, so we built UniRep to solve this problem. Yeah, so the UniRep means universal reputation. and it's a private and non-repudiable reputation system. And users can give others the positive or negative reputation. And also users can voluntarily prove that he has certain amount of reputation. For example, you have like 100 reputation and you can voluntarily prove that, oh, I only have 10. Yeah. And user cannot refuse to receive bad reputation from others, right? And yeah, and I will introduce how it works. And so there are two actors in UniRep. One is a tester and another is users. And the attester is like application itself. So it is public information that everyone can see this the attestation is from which attester. Yeah, like the attester can like issue reputation token to others. So everyone will see, oh, this is the application token or B application token. And there's another role called users, and user can receive this reputation and prove how much reputation I have. Yeah, and how can we achieve privacy is that a user can generate a temporary identity called EPA key. And user can generate like K EPA keys in one EPA. And for example, an EPA is like 7 days. And if they are all EPA keys, and you cannot link any EPA key to one identity. Yeah, the EPA key is like just the random number in the UniRep Social. Yeah, and I will demo the UniRep Social, and also you can scan this link to our website, or you can just type the unirep.social, so you can link to our website. Oh yeah, and now the UniRep Social requires an invitation code, and we brought some invitation code. So after this presentation, you can ask us to give you invitation code. Yeah. So this is the social media like this. I just log in, and you can see. Yeah, this is my rep, and people can. Oh, I should. If you enter this website, and you can use join and enter the invitation code to join this system. And yeah, and also you can request here, and our colleague will help you to join this. And yeah, after you sign up, you will enter this website, and you can publish a post, like for example, ZK workshop. And I can choose these 3 identities, three personas I have, and they are all like random numbers, so everyone cannot link anyone to anyone to myself or to an identity. And here is the reputation display. Like I said, a user can optionally prove that how many reputation I have. So I can scroll this bar, and I can prove I have 100 reputation here. Yeah. And in this system, we don't want the post to be like no cost, so we ask users to like spend 5 reputation here to post. Yeah, so you will receive 5 negative reputation if you publish the post. Yeah, and it has to generate proof and to submit to the blockchain. So yeah, let's wait. Yeah, it's finalized, so you can see my post here. Yeah, and you can see the transaction on Etherscan. Yeah, and after sign up, you can vote or upvote or downvote my post. And you can also choose the identity you have. And also you can comment here, right? And also then you can choose the identity and reputation you want to display. Yeah. So, so how user can sign up in this UniRep protocol? We use the semaphore identity, right? Like Jeff said, we can use this identity and identity commitment to, we use this identity commitment to sign up in the UniRep smart contract. And there's a global state tree, and it stores the hash of your identity commitment and your user state tree root. And what is the user state tree? It is your state of reputation. Yeah. So the length of the this user state tree is your hash of positive reputation and negative reputation, and also gravity and sign up flag. And you can just imagine that you have positive and reputation and negative reputation. And the other two is like to make your reputation more diverse, so you can make more application in this reputation system. Yeah. So you know that there are attesters in this protocol. So the index of each leaf is the attester ID. Yeah. So so this is sparse macro tree to store all your reputation state. And what is the global state tree? Is that you hash your ID commitment and the user state tree root. Yeah, so there will be another hash to insert into the global state tree. And it is an incremental macro tree that the first user signed up, and it will insert in the first index. Yeah. And it's all public data. So, in this user state tree, your reputation are private, right? So you don't want others to see your reputation. And in this global state tree, the hash value is a public data. And if your leaf is inserted in the global state tree, it means you are signed up and you are a valid state in this UniRep protocol. And how a tester sign up? It just use the attester's account or a smart contract to sign up through UniRep. Yeah, so the UniRep contract will store the address and to assign an attester ID to this attester. Yeah, so in the UniRep Social example, the UniRep Social itself is an attester in this protocol. Yeah, so to sum up, user will use their identity commitment to sign up, and a tester will use this address to sign up. And how can user generate the epoch key? The epoch key is computed by the hash of her identity and epoch and nonce. Yeah, but how can we make sure that the user has already signed up in the UniRep protocol? And how can we make sure that the epoch key is computed correctly and it is not a random number? So we use a ZK proof to prove that this epoch key is valid and compute correctly. So in the epoch key proof, it will compute the epoch key itself, and also it shows the global state tree root. So you will see if it matches the current global state tree root, and we can make sure that this user has already signed up in this system, in this epoch. So if after users generate the epoch key proof and the epoch key, and they submit this proof to smart contract, and the other users can give attestation to this epoch key. Why we have to submit this proof on-chain? Because we have to, we like everyone to verify this proof is correct, and then this user is allowed to receive reputation. Yeah, and after this, after the user gives the reputation, it also stored on smart contract, and the reputation has to be compute a hash chain, and the hash chain is to hash all the reputation. Yeah, like the reputation is, hash of the reputation is computed by the attester ID and positive reputation, negative reputation, and other two variables. And in this way, each epoch key can generate their hash chain. So the user cannot ignore any reputation because, or the hash chain will be totally different. Yeah, so now we have reputation here, and how can users receive this reputation? There's a action called epoch transition. And after this epoch transition, we will hash all the, sealed all the hash chain, and it will compute another tree, another global, another tree called epoch tree. And the epoch tree is its value is the sealed hash chain, and its index is the epoch key, right? So the all the reputation in this epoch, it will generate another tree, and other one, all the users know this epoch tree, right? So you can verify if your epoch key is indeed in this epoch tree, and you don't ignore any reputation. And user has to generate another proof to perform user state transition, right? Because user has its user state tree, and we have to update this user state tree. So the user has to generate a proof that to process all the, like, yeah. For example, the user state tree is empty, and we receive the reputation 1, and I update my reputation, my user state tree. And if I receive another reputation, and I will sequentially update my user state tree. Yeah. And in this circuit, we also compute all the epoch keys you have. So in this circuit also it checks if the hash chain and the epoch key matches the current epoch tree root. Yeah, so after we update the user state tree, and user will have another global state tree leaf to be inserted in the next epoch. Yeah, and we have a nullifier called epoch key nullifier to prevent user from perform user state transition more than one time. Yeah, and after user state transition and user state tree updated, and the user can generate the proof to prove how many reputation the user has. Yeah. The idea is that I can prove that one of the leaf in the user state tree, and also this leaf is in the global state tree. Yeah, so the overview is like user and attester sign up here, and user can generate epoch key proof, and others can give reputation. And the epoch transition is to seal all epoch key hash chain and build a epoch tree root. and user perform user state transition to receive all this reputation he has, and update the user state tree, and then he can prove his reputation. Yeah, thank you. Any questions?
In your app, the social media, since the identity is it's not known, how do you follow someone? How do you know who you're following?
Oh yeah, good.
And who sees those first posts? I don't get that.
Yeah, so the question is that how I can follow it and the author in this social media, right? Yeah, so this is the things we will do in the future. Yeah, we will like to let user to have their username so I can subscribe this username. But we haven't done this feature right in this social media right now. Right.
Can I ask
Yeah.
another thing? How do you I heard anybody can give you a bad reputation and you cannot refuse, of course. Now, how do you counteract for the fact that most people are prone to, when you see something you don't like, you react to it and you give a bad reputation, but not so much when you like something. So at the end, if you don't have a way to counteract that, you'll end up canceling everyone.
Oh, also you mean that how can we prevent user to downvote anybody without any cost?
No, it's to take into account that you're gonna get more bad reputations than good reputations, and normally, because when people are offended for something, it's very easy for people to give a bad reputation. But most people don't go in to do a review for a good thing that they saw, at least not for most things that they see.
Oh, do you mean
so there is more bad reviews than good reviews normally.
So you mean the bad behavior users? How can we prevent them? Right? Like
no, what I'm saying is you're gonna find a natural bias in people giving bad reputations. It's usually in more than the people that will give reputations to good things. So at the end, it will tend to, unless you have a way to counteract on that, a percentage or something, tend to get people all with bad reputation.
Yeah. Okay. So like, the first thing. So let me repeat the question just to make sure I understand. Like, you're basically asking that like people are bad and they don't do good things.
No.
They have emotional reactions to stuff, and I don't think that we can have a zero-knowledge proof solution to this. However, there's two things that like mitigate it. Like,
Oh, sorry, no, that's not the. People are good, but when it comes to reviews, the reaction of people. I mean, you see a lot of good things every time.
Yeah.
You normally don't go, oh, that's good, I'm gonna give it a good review. No, that's good, I'm gonna give you a review. But when you see something wrong, you tend to, oh, I'm gonna give it a review. Right. Because I don't like this. So you give a lot of bad reviews, okay, and not so much good reviews, so it will be skewed.
Like this is like, it costs to give negative reviews and it costs to give positive reviews. So like the system will equivalate, it come to an equilibrium around this.
Even more, because you were not gonna pay your reputation to give a good review, but you will for a bad review because you didn't like that.
In the interest of time,
yeah.
We'll get a quick response and then do one more question.
yeah, thank you.
Sorry about that. Do you want to take one more question?
Yeah, for sure. You can talk?
Oh.
Thank you for your talk. So as an attester, how much information do I have to reveal and how much information can I keep private? Like, can I attest anonymously? Can I only reveal the positive? Can I conceal both the positive and negative?
Also, as the site, the site up attester, it cannot be anonymous. Yeah. So the you give reputation is public, and in this system, the attester cannot generate the epoch key, and another proof. Yeah. So if you want your privacy, you have to like act like a user in this protocol. Yeah.
Do you want to do one more, or should we? Okay, yeah, let's do one more question.
Yeah. Thank you for the talk. I think it's a very interesting topic. So, one of the things that that I want to like in the close future is a way just to integrate all these kind of things without the permission of the providers. Yeah. So, for instance, there's some tool that exists that is called TLS Notary. That is a way just to use the TLS protocol to get a proof that this website generates something. So, do you think that we can? There is a way to do this. Do you think that we can find a way to just to bypass providers' permission for this kind of claims?
So I think that that's more to do with like making the groups. That semaphore kind of consumes the groups, and like you're saying, how can we make these groups in a trustless way? And there's all kinds of things we can do, like trustless TLS notary, to like make these groups in a like it's still a kind of trusting that like, but the set of people you have to trust is reduced. It can be just done unilaterally on the part of the user with TLS notary. Yeah, I think that like as time goes by, we're gonna have to get better at like having on-chain reputation sources. That like I think about InterRep and TLS notary as kind of bootstraps, because we have this like chicken and egg thing where we want more groups, we want more applications, and we need to have some groups so we can have some applications. And as soon as we have some applications, we'll have some decentralized groups as well, or we'll have more. That's my thinking. What do you think, Vivian?
Okay. No.
Okay, sorry.
Thank you.
All right, thanks so much, Barry and Vivian.